In this video, I want to have a look at the equations of straight lines. So first off, we'll just start really quickly looking at the equations of vertical and horizontal lines. So any vertical line is going to have an equation of the form x equals a, where a is a number. So for example, if we had the line x equals 2, then any point that lies on that line is going to have an x-coordinate of 2. So some of the points that lie in that line could be 2, 0, or 2, minus 20, or 2, 100. Any point that has a 2 as the x-coordinate is going to lie on that line. It's really similar for horizontal lines, except the equation is going to be y equals some number. So for example, if we had y equals minus 10, then any point on that line is going to have a y-coordinate of minus 10. So it could be 1 minus 10, it could be 7 minus 10, it could be minus 3,000 minus 10, but it's always going to have that minus 10 as the y-coordinate. If we start talking about straight lines that aren't vertical or horizontal, there's lots of different ways that we can write their equations. Probably the most familiar to you though is what's called the gradient intercept form of a line, and it looks like this here. So you've got y equals mx plus b, where m and b are both numbers. This m here, so the number that's the coefficient of x, that represents our gradient. And the constant number on the end, so the number that the b is representing, that's going to tell us our y-intercept. So the gradient intercept form of a line is fairly familiar, and it's pretty useful as well because we can read that gradient and y-intercept straight off. Another way that comes in handy though, so it's useful sometimes, is what's called the general form of a line. And that's when we write it as ax plus by plus c is equal to 0. So that those a, b and c, they're numbers, and we're actually always going to have them being whole numbers or integers. So if there's ever a fraction there, we multiply it through to get it out. And if there's a common factor in there, we'd divide through by that as well. When we're writing it as general form as well, we always make sure that that a is a positive number, just because it makes it a little bit nicer. So it's a whole number that's bigger than 0. So we want to run through a few examples. Our first one asks us to write down the equation of a line with gradient 12 and y-intercept 2. So we know that the gradient intercept form of a line is y equals mx plus b. This gradient is our m, and the y-intercept is our b. So the equation of our line is just going to be y equals 12x plus 2. Our second example asks us to write down the gradient and the y-intercept of the line y equals a half x minus 7. So we know that our gradient is going to be the coefficient of x, so the number in front there. So our gradient, or m, is going to be equal to a half. And our y-intercept is the constant term on the end. So that's this minus 7 here. So our b is equal to minus 7. Our third example asks us to, again, write down the gradient and y-intercept of a line. But this time it's not immediately given to us in gradient intercept form like our second example was. So what we're going to do is we're going to rearrange it to make y the subject. So that'll put it in this gradient intercept form, and then we can read those two values off. So if I just rewrite it first, we've got 4x minus 2y equals 16. So we're trying to make y the subject. So let's get rid of this 4x term first. We'll do that by subtracting it from both sides. So over on this left-hand side, we'd have minus 2y. And then over on the right-hand side, we'd have minus 4x plus 16. So then we need to get rid of this minus 2. We'd have to divide everything, so every single term, by minus 2. So we'll have y equals, now minus 4 divided by minus 2 would just be 2. So we'll have 2x. And 16 divided by minus 2 would give us minus 8. So now it is in gradient intercept form. So our gradient is that coefficient of x, which is that 2. And our y-intercept is the constant term on the end, which in this case is minus 8. Our last example asks us to find the equation of the line perpendicular to 2x plus 6y minus 5 equals 0 and passing through the point 0, 5. So because we want the line perpendicular to this one, the first thing we're going to have to do is find the gradient of this initial line. So if we've got the equation 2x plus 6y minus 5 is equal to 0, we're going to have to rearrange this into gradient intercept form, so we need to get the y as the subject of the equation. So let's move the 2x and the minus 5 over to the right-hand side. So we're going to have 6y equals minus 2x plus 5. Then we can go through and divide everything by 6. So 2 divided by 6 would give us 1/3. So minus 1/3 x plus 5 over 6. So that means that the gradient of this line that we were given is minus 1/3. But we don't want the gradient of that line, we want the gradient of a line that's perpendicular to this. So we know that the sort of relationship between those is that the second gradient has to be equal to minus 1 over the first gradient. So we're going to have minus 1 over minus 1/3, and that would just come out to give us 3. So the gradient of the line that we're looking for is 3. But to find the equation of that line, we also need the y-intercept. So the other piece of information that we were given is that it passes through the point 0, 5. Now, because this point has an x-coordinate of 0, that means that this point lies on the y-axis. So this is our y-intercept. So y-intercept of 5. So the final answer then is going to be our line has the equation y equals 3x plus 5. So those are a few examples of equations of straight lines.